Okay, so this is G485 Homework Booklet 23. We've got a fairly standard fission reaction binding energy type question. So we said that with uranium-235 we absorb a slow moving neutron, absorbed by the uranium-235, and ultimately it's ending up with this barium and krypton, is it Kr? Ask the chemists. Of course, we know that in between there's a stage where we've got the uranium-236, so the neutron's absorbed by uranium-235, it becomes uranium-236, that then undergoes fission. We've got to explain how the reaction is able to produce energy, and it's all we need to say is that the mass of the uranium-235 is bigger than the mass of the products, and therefore by E equals mc squared we end up with energy being released because we've dropped mass. The other way of saying that is that the binding energy of the uranium-235 is less than the binding energy of the products, and the energy that is released is the difference between those two energies. And that's what we're going to actually use when we get down further in the question. In what form is energy released in such a reaction? In essence, you could say that it's thermal, but because we're talking about the particle level, they want you to understand that that is kinetic energy of the particles. Now, yep, that is thermal energy, but they definitely want you to say that it's kinetic energy of the particles. We're given some binding energies. The binding energy per nucleon of each isotope in that equation is given, and there they are. The question then asks us to explain why a neutron doesn't appear in the table, and it's not bound. So it's a single nucleon, cannot be split, is not bound. It doesn't take any energy to split it from the other nucleons it's attached to, because it's not attached to any other nucleons, so it's got a binding energy of 0, doesn't need to be in the table. We're then asked to calculate the energy released in the reaction, and very simply work out the binding energy of your reactants. So in this case, remember the numbers I've got are binding energy per nucleon, so I'll use the nucleon number 235 multiplied up by the 7.6 mega electron volts of binding energy per nucleon, and I get the binding energy of the uranium. I'll take the 141, multiply it by the 8.3, and the 92, multiply it by the 8.7. That'll give me the total binding energy of the products. 197.7, take one from the other, and I get with 185 mega electron volts. So that's G485 Homework Booklet question 23.